Excellent.
There we go. Okay.
Good afternoon. My name is Judson from Microsoft. I'm a computer scientist. My colleague, Felix, and I have another colleague on the side, Ville. Take a gander over at Ville. He's manning our demos. So after our talk, we have a few things we can show you, code you can download, and things you can browse with Ville to see how we've done the things we're talking about up here. All right, and off we go. So the Internet of Things is big. Everyone has talked about that, billions and trillions of devices. It's also fairly complicated. It's the kind of place where, at least in the very early stages of the Internet of Things, people tend to try to prototype lots of stuff. We see things in the makerspace, which is not as relevant here, but we see things coming out of the makerspace like light bulbs you can control, servos you can flip on and off. And they're typically circuits that people work on. The problem is software is hard and hardware is hard. And it's common that most of the time, the people who are building hardware are not software experts, and the people building software are not hardware experts. So our opportunity here is to understand how to accelerate what's going on. So the panelists who were here before us were talking about how alliances can partner and cooperate. We actually want to catalyze the process. We don't want to wait, right? As Microsoft, what we care about is actually getting to the bigger questions. And let me give you an example of what we mean by some of the bigger questions. When you're collecting data from trillions of devices, are you asking, is my light bulb going to die? Or are you asking, what are the traffic patterns of the fish that are swimming in migration? And how is pollution affecting their migration path, right? Or are you asking, if I design this drug in one direction or another, what's the efficacy when it hits the distribution channels and gets to market? Is the supply chain happening fast enough? Is manufacturing happening fast enough? Where are my faults? Where do I have lost costs? Where do I have missing profits? That's the kind of question the Internet of Things enables us to ask, not, is my light bulb on or off? Right? So I want to get you to think a little bit bigger, and I would say a great example of how to think bigger that I kind of wish the panelists, I could have primed them before they got here, is think of the Internet of Things as something even bigger than building the International Space Station. Right? We're all pretty familiar with the International Space Station. Think of how many countries collaborated, how many technical systems, how many places for failure, how much software is running, and it's generating power, supplying oxygen, and doing things that for life support all the time while they do science, right? So that's the scale of problem we have in making the Internet of Things work.
Yeah, the basic trouble here is that if you think about the Internet of Things and compare it to what we had before, which we could just call the Internet or the application Internet, there's just a lot more things that we have to connect with each other and a lot more things that need to cooperate and interoperate. We heard it a bunch of times today that it doesn't really work when every single provider builds their own hardware, their own software, their own application, and for every single light bulb that I have in my room, I have one application and I need to open 5 applications just to turn off the light. The downside that comes with that is that we have essentially 4 pillars where there used to be only one. And I think speaking as Microsoft, we know that building hardware and software in the cloud infrastructure is pretty hard. I think other companies have made the same experience. But the bottom line is that it's very likely that if you focus on one of these areas, you will do a better job in that one area than if you try to build one holistic solution that works well. The bottom line is what we're trying to say is it is very likely that if we don't cooperate as an industry, all of us will probably have at least one weakness. We might have an amazing device, but we will probably have a somewhat, shady application. We might have a good application and a good device, but our cloud security might be lacking. There's various areas where you just need a gigantic amount of domain expertise that it's very unlikely that all of us will succeed in all of these things. So our solution is essentially saying that's quite a bit we have to build here. We need to move beyond just all of us working on our own thing. We need something that is bigger than that. We need to cooperate as an industry.
I think Felix's point about the complications and the issues is well highlighted in what we see in our demonstrations even here today, right? So the Higgins application, which we can see over here, and Musley are examples of software that integrate multiple vendor solutions, multiple hardware stacks, multiple software stacks. And we're looking at the handful at the beginning, right? As this thing rolls out and it gets exponentially more complicated, how many Higgins have to exist? How many Musleys have to exist for home users to actually get what they want out of home automation? But even broader than that, when we look at the Internet of Things in context and we have connected car, quantified self, home automation, smart workplace, how many of these Internet of Things contexts are actually going to be able to fit together so that I as an individual can move seamlessly from my home to my car to my workplace? And really, from our point of view at Microsoft, our sort of mantra lately has been, we want to increase productivity. So how do we make human beings more productive throughout those contexts? How do we leverage the Internet of Things to actually enable users to stop doing the things that they waste time on and start spending time doing things that they're productive and enjoy? Now, we can't necessarily eliminate work entirely, which might be my goal, but I think what we can do is we can optimize the system and create some efficiencies.
Right, and we did bring an example. Microsoft recently launched something called Microsoft Ventures, and we have one giant accelerator in Seattle where we took in a bunch of IoT companies and worked with them on IoT scenarios and devices. And one of those companies is HeatWorks, and it's at the bottom line, if you think about it, a very simple scenario. This is a machine that, heats water. That's pretty much it, just increasing the heat in water, something fairly simple. But something Ivan is going to do, Ivan is going to quickly show you and walk you through just the broad architecture that is involved in creating the user experience of having a connected water heater.
Yeah, so here's a case study in a way. HeatWorks has this hot water heater. It's a small company, between 10 and 15 people, right? The founder of the company, who is is the CEO at this point of the company, has a track record of building businesses and doing well at startups. This is his next venture, is building this hot water heater. This is a direct heating hot water heater, 99.9% efficient. It can heat anything that has minerals in it, so distilled water and RO water don't work. It can heat mud. It's amazing in terms of the technology, and it's incredibly simple. It's got some conductors, and it's got this board here. And the beauty of this board, if you look right there at the top, that big empty square with the orange connector, that's where the all-join interface goes. So the problem is, with 14 people at this startup building a hardware device to heat water, they have mechanical engineers, they have electrical engineers, they have business development, they have management, they have one sort of HR office manager, jack of all trades, and they have a bunch of other supply chain management people. How many software engineers do you think that they have at this company? Come on, you can actually talk, it's okay. Maybe one who writes firmware, right? Security, well, it's proximal. If you can't get in my house, you can't mess with my hot water heater. That's totally fine for this market, right? Our current hot water heaters aren't secured any better. The problem is, what they have to do is they have to now, in order to get their hot water heater to market, they have to look at what's my cloud infrastructure? How do I wire this up so that I can manage and do service calls on these things remotely? What's my storage for, say, tens of thousands or hundreds of thousands of hot water heaters in market that I'm collecting this data from? Daily usage, failure rates, issues that come up, firmware pushes, things like that they don't do, right? This is not what an electrical engineering company does. And worse, how do I build a mobile experience? If I'm in my house, I don't want to have to go crawl under my kitchen sink and turn a knob when I can just sit here with a mobile app and go, I'd like it hotter. Oh, and by the way, because it's all joint enabled, they actually have a model for, I walk into the shower and it knows that I'm me and sets the temperature within 1 degree to the preference I have. So that when my wife walks in, it's to her temperature. And when my teenager walks in, at 10 minutes, it starts reducing the temperature by 1 degree per minute so that they get out, right? I mean, that's the Internet of Things making value for me. But if I'm a Heatworks building this Model 1 hot water heater, how do I have the staff to acquire all this core competency? That's a huge amount of cost for my business. So what we can do is we can partner both with the AllSeen Alliance, the other AllSeen partners, but also as Microsoft to bring our expertise to bear in cloud, in security, in mobile, in these various areas. And so what we've done is kind of, I think we're on the what we've done part, but
Okay.
I'm not sure. But I think the only way we can do this in the large, right? So Heatworks is one company, which is fairly small. Microsoft is one company, which is not fairly small. We could easily help Heatworks get this thing to market and solve this problem. But in a market of trillions of devices, how do we do it at scale, right? How do we really help these devices become powerful and useful at scale? Well, we believe strongly that the way we do it is through collaboration and specifically collaborating around open source solutions.
Right. And I think that's a point where we should briefly talk about what we actually mean by that. We're going to explain in a moment why we're open source engineers and what that means. But there is a number of components here that are involved, and I think as software engineers, application engineers, we do have a certain amount of experience with what it takes for a certain protocol or a certain standard to become viable and successful. There are a bunch of examples that we all know: email, web browser, the basic things of the internet today. Those were certainly, from where we're standing today, a lot simpler than what we're seeing before. But it took a certain amount of time before you could build an application and use a Facebook login to log into that application. That took a certain amount of negotiation between developers, the companies involved, the standards that are involved. And we're trying to grow and basically promote the same type of approach in the Internet of Things, where we have a lot more partners that are not necessarily used to the whole idea of open source. Certainly a lot less used to it than maybe the software developers. And certainly for Microsoft, I think Ivan and I, we both still remember all the talks we had with our own legal department whenever we talk about open source. There's a lot of red tape that needs to be cut, and we're trying to cut that red tape. But basically, we need three things. The first thing is we need open source code, we need open data, and we need open APIs. We need an environment in which it's easy for other developers to understand what we're doing, why we're doing it, how we're doing it. If I'm coming up with the next big IoT thing, or I'm building the next big IoT application, it shouldn't be hard for me to integrate with that light bulb, that speaker. I shouldn't have to specifically think about those things. I shouldn't have to take a single meeting for my application to work with your light bulb, to say it very simply. The second thing is we need to build partnerships, because we're not really quite there yet. We can't just go out and make a bunch of proposals. So do you want to talk about the partnerships?
Sure. I think that one of the things that I would highlight that Felix mentioned with the open source and open data is, if you remember back around 2000, the first attempts at this in the web space were web services, right? And we did all these strange XML-based protocols and APIs. And our theory was, if we do this, then developers will write software and integrate all these things, and magic will happen, and innovation will occur, and the level at which knowledge and value increases will go quickly. I think what we learned in that is, when we balkanize the implementation of those through proprietary partnerships or consortia that are competing rather than cooperating, which is to speak to some of the points made in the previous panel, we create an environment in which we stifle that innovation because it's hard. What we've seen in the last few years is we've seen a fairly solid, I would say unofficial cooperation, that doing things with RESTful APIs and using JSON for data transfer has essentially become a de facto without anyone mandating it. Because if you want your stuff to be used, that's how you publish access. And I think that is what gets us to the point of building partnerships. And I think we are in this transition right now with AllSeen and in the Internet of Things where we don't have to keep building cool little objects. We've got lots of LEDs that blink. We've got thermostats. We've got hot water heaters. We've got a variety of things at many levels in complexity. We need to help them publish and promote access in an open way because we have to move up the stack one level. We have to move to the level at which now the devices start talking to each other and communicating. And I would say the point of AllSeen that I haven't seen highlighted today, that I think is the most exciting from Microsoft's point of view, is when your smart home is smart enough not to ask you when to do something, right? When I walk into my shower and it knows it's me and it sets the temperature to 103 because that's what I like, I didn't have to do anything on a day-to-day basis to make that happen. That's the vision of where we want to go, not, oh, I've got this API for my thermostat, and you've got this API for your thermometer, and you've got this HVAC system. Write this code and make it. No, we have to get past that to the next level. So partnerships are the only way to do that because the hot water heater guys are going to build hot water heaters. The HVAC guys are going to build HVAC systems. The thermostat guys are going to build thermostats. Appliance guys are going to build appliances, and they have to work together. That's where the partnerships come in.
And that's also where the user experience comes in. We're currently at MWC, and I think if there's one thing we can say for certain, and that's also something we can say as Microsoft, it's a pretty brutal reality, but if you're building an IoT-connected device, we're currently at the beginnings of that, but I certainly expect that within a few years, IoT devices are going to be in the same market as phones. And quickly raise your hands. Who has bought a phone because of the megapixel number on your camera? Nobody. One person. One person. Okay. The point that I'm trying to make is that we will very quickly reach a point where what you're actually building doesn't really matter anymore, right? There's going to be a certain point where every single water heater is going to be somehow connected. And I don't really care what kind of water heater. What I'm going to care about is what is going to be the Facebook of IoT. I'm going to care about what runs my Facebook best. It's going to be the bigger application around it. And we as Microsoft have made that experience, right? One of the biggest challenges for Windows Phone remains not that it's not a good device or that it doesn't have a good operating system. One of the biggest challenges remains that if there's one reason why people would rather pick up another phone, it's usually that they were missing a certain application. And the best thing we can do as Microsoft is go to that application and work with those developers together to get the application on Windows Phone. But that's what's going to happen in the IoT space, without a doubt. What's going to happen is that the actual devices and the feature set is going to become irrelevant at the point where we have real applications, at the point where I walk into my shower and I don't have to set anything. At that point, it's going to be about who is integrated into that ecosystem of connected experiences the best, who's going to deliver the best user experience, not by necessarily building it themselves, but by integrating so well with all other devices that the user experience is going to kind of grow as a mesh.
So then the next thing we want to do after that is once we have the partnerships in place, we need to grow the communities. And what I mean by that is if you're in business, right, you think of a typical timeline that's something like I have an idea, I bring it to market, right? You do that solo, you protect your IP. Then you build distribution and partnerships. Who do I get this out through? How do I get partners to write product, software and integrations with my product? And then the last thing you do is typically marketing and pricing, right? The way I think about that as an engineer is I get my idea and I get it instantiated, I build partnerships, and then the last thing I do is actually I grow a community. And what I mean specifically by grow a community is grow a market, right? Trillions of devices, billions of opportunities, limited number of players in the game, a growing number, and we've got a huge market that we need to actually stimulate to understand the value. And so after we have partnerships and we have those things happening, then we need to be externally facing. We need to look for applications where we can improve the human condition with our IoT solution because we grow and expand the market in those places.
Right. So let's very briefly talk about what the hell that actually means. We keep including that in slides every now and then, because usually whenever I go on stage, I'm like, hi, I'm the open source guy at Microsoft. People are like, what?
And you're alive.
Right. It's a fair statement. So our team is kind of new. Microsoft, it has taken Microsoft probably more years than many other companies to realize that open source is probably the best way to advance the whole industry. And we're still at a point, certainly in IoT, like probably in IoT more than any other industry, where we have to solve problems and we're going to advance as an industry for a very, very long time, right? For us right now, we have to get the user experience right so people are actually going to use it. It's less about beating the other people. As a whole industry, we can very well cooperate together and all win. This is not a zero-sum game. So what Ivan and I do and what Ville does and what we all do as a team is that we write code, not necessarily for the end consumer, but we write code for other developers, for other companies, so they can use it, which is why it's open source licensed. It's a free license. You can do whatever you want with it. And we cooperate with startups, big corporations, other companies to integrate that open source code into their solutions and to optimize the code for their solutions. And at this point, I don't know if you've seen it, but Microsoft has slowly open sourced a bunch of our core technologies. If you ever heard of C#, it's the holy grail of Microsoft. C# at this point is entirely open source, 100% open source. You can see the whole thing on GitHub. We have about 840 repos. That means 840 products that are entirely open source. They were just put out there not because we suddenly feel like we need to fix the world, but because that's really the way to go as a corporation and as an industry. We need that open collaboration because we are more and more growing to this mesh where everything is kind of connected. And in order to have that connection, you just need to be open about what you're doing, why you're doing it, and how you're doing it. The bottom line here is that we're not really building products or anything. We're not trying to sell you guys anything. We're trying to solve problems in the hope that we as an industry are going to advance. And as it turns out, that's what we put on this slide. It turns out that the IoT currently has a lot of problems to fix. Our team is probably not going to fix a large number of them because there are so many out there, but we're trying to contribute, and we're also trying to get other members in the industry to also move into the direction of open source. So with that in mind, let's talk about what we have, right?
Sure. So with that in mind, we can point out that there's a lot of things that are going on within Microsoft, both from open source and from IoT points of view. We've got a lot of devices. We've announced a lot of devices. We've got Kinects, we've got Xboxes, we've got phones somewhere.
HoloLens.
I've seen one.
Yeah,
and we've got HoloLenses that we've announced. We have a ton of devices across the spectrum, including Surfaces and PCs and all sorts of stuff. And we've now turned the corner in a way, and we announced this week the One Core initiative. So the goal being that all of these devices will run a common core of operating system. They might have extensions for devices, but there'll be a common API set that'll be available on all these devices. And in another area, so I'm going to carefully separate the next statement from the previous statement. In another area, we have also, you've seen in Windows 10 technical preview, there's an all-join router running as a service on the system. That is, at this point, our plan that every Windows 10 device will have an all-join router running on the system. If you are careful and you have searched through the internet intentionally, you will also realize that there are all-join APIs that are getting exposed in Windows 10. There's more information coming on that in the near future, so I can't go into any details. But we have invested fairly heavily in all-join as a company. Inside our operating systems group, there's a team who is dedicated to making this happen. They are rock stars, and they are doing a phenomenal job. And even more encouraging about that is that that team is working very closely with the AllSeen Alliance and making sure that everything that we do with all-join can get pushed back into the Alliance as improvements to the shared code base so that other people can take the things that we find and fix and leverage them for their operating systems and their software. As an anecdote, I want to say there's a very interesting turn, even as we open source product code and we talk about Microsoft and open source. The AllJoin code that's on the AllSeen Alliance site, if you go to the developer section of the AllSeen Alliance and you download the AllSeen code, that's what our operating system team started with as they put AllJoin into Windows. I want you to think about that point very carefully. Microsoft, as a company, has gone so deep in its commitment with AllJoin as to start with the open code that you can download and build and integrate the pieces into the operating system that we can. That's a major fundamental change within our development process. And it's awesome. It's actually one of the reasons why I considered joining the team.
Right. So what this underlines, that is essentially the first-party approach, right? That is how we as Microsoft integrate AllJoin. That is what we as Microsoft do with AllJoin in itself. The upside being that we have well north of more than 1 billion devices out there. In theory, all of them are going to be able to very quickly become AllJoin devices. That's kind of the idea here, right? Just putting a bunch of zeros next to all the AllJoin devices out there within a few months. But the next thing is that we have to go beyond that, and we have to, as Microsoft, think about what happens with all the other devices. Because again, I'm going to reiterate this point a bunch of times, but Microsoft, the company that now also released Office for iOS and Android, whatever we're going to do in this IoT space, Microsoft could do many things in the IoT space. If they don't run on Apple, if they don't run on Android, if they don't run on any other devices, it's not really going to matter that much. It's going to be nice for a bunch of people. We're going to make a bunch of money. But it's not really going to move anything dramatically forward, right? So we wanted to think about the next levels. And let me quickly show you this. The idea that we have here is that what I'm briefly going to talk about is the cloud level, which is going to still first party, but with everything else. First party with everything else. And then we have the Cordova approach, which is going to be entirely agnostic. So let me briefly talk about the cloud piece. Because the cloud piece is interesting. We're trying as a company to think a couple of years ahead. And we're trying right now to turn on light bulbs. And last night we blew out a circuit and the power went out. But if you think a couple of years ahead, we're probably going to fix this at some point and move towards an area where we're going to have huge amounts of data. That is something we're seeing right now. We're working with a bunch of companies where a single device has a bunch of sensors. All those sensors send information per second. And we very quickly reach levels of information where we have serious data problems in areas that would usually not be a problem before. So let's start with something that we call event ingestion, the so-called event hub. Think about any device out there. I'm going to take a car as an example. Think about a car. Think about all the kinds of information you can get from a car in terms of data sensors. Think about 1 million cars out there that you happen to have. And think about every single car sending, I don't know, 50 or 100 data points per second. It's actually a lot more, right? It's actually thousands of data points per second. It doesn't take a lot of complex math to realize that very quickly you need some kind of endpoint, some kind of server, something that is capable of accepting essentially unlimited amounts of data.
Let me interrupt you for 1 second.
Yes.
Brett, can you tell us ballpark the amount of data that comes from a single car? Yeah. Just sort of a ballpark.
That's abstracted data points. That's not the actual core data points. It actually gets to be too much.
It was 25,000 how often?
25,000 data points on our average trip, which is generally about 14 minutes of driving, and that's abstracted. You could actually, inside the vehicle bus, you're generating gigs per day.
Okay, so there you go. If you have to build an infrastructure for that, if you are not in the business of, I mean, let's just put this in perspective, right? Building Twitter is kind of nothing compared to that. If you put it in this perspective, it's going to take the whole industry some serious heavy lifting to get this off the road. The first building block we have out there, which is available today, is Event Hub, which is capable of accepting a nearly unlimited amount of data from virtually any kind of data source. And it allows you to accept that data, process it, analyze it, do other things with it. It's general purpose. All it does, it gives you an endpoint that allows to accept all kinds of data, and then you can do things with it. It's a pretty major piece. It's a tremendous amount of engineering. Setting it up takes about a minute. That's the funny piece. There's like a whole thousands of engineers have sweated over this for weeks and months, but now you literally say, I need an event hub, and it takes about a minute, and then you have it, which doesn't really have the certain amount of oomph that I would like it to have, but that's just how it is. So now you have your millions of data points on Event Hub, and ideally you want to do things with them in some type of low latency manner. Things get real interesting once you enter the real-time data market. Event Hub can be plugged into anything that you have. It can be plugged into anything running anywhere. We have our own solution for stream analytics, which is essentially comparing the data that is coming in, looking at it, roughly processing it, and doing small things like comparing it with some kind of model, a data science model, comparing it with historical data, comparing it with other data points. Because the interesting piece about Event Hub is once it reaches the analytics phase, it's not just your device, right? It's other devices too. It's all kinds of applications that are online. It's maybe other sensors that are out there. If you combine all that information together, you can do very, very interesting things. And people kind of race each other, trying to come up with great scenarios for what they could be. But a couple of defaults are that you can alert, you can just create a mathematical alert, you can detect anomalies in your data points, which is interesting for all kinds of things, right? That's just a very basic example. The applications here are kind of unlimited, but the idea is that you look at your data automatically, you run a small model, and you do all that in real time, and then do things in response to real-time data. For instance, if you think about planes, finding a missing plane or realizing when a plane has gone off course shouldn't be that difficult anymore. Weather analytics, fleet management, unlimited amount of examples. And then the next piece that we have, which is already available, publicly available, is machine learning, which kind of takes both things together and does things that are a bit bigger than just doing it in real time. The amount of processing you do in real time is somewhat limited. What becomes really interesting is if you look at the data that you have and analyze it in a machine learning context. Machine learning in itself is like this whole industry, so I'm not going to go too much into depth. But essentially, quick example, if you go to Netflix, and Netflix roughly knows what kind of movie you would like. If you go to Spotify, and Spotify has an idea what your taste is. If you go on Amazon, and Amazon has an idea that because you bought item 1, you might be interested in item B, that is machine learning. That is a machine looking at patterns. That is a machine running a statistical model on the data that is coming in. We currently can do that very well with a very small number of data points. Like Netflix knows, for instance, what movie you started. It doesn't know whether or not you actually looked at it. It doesn't know how many people were in the room. It doesn't know who was in the room. There are a bunch of things how you can refine this. But it's already pretty successful. People like this machine learning type of thing. And we expect that once the IoT actually heavily takes off, with more data points available, we can probably do much more than just knowing that Ivan has a certain temperature for his shower. Once we apply machine learning, we can learn way more things. There is currently a company in California that is essentially just running a brute force attack against AIDS. They're just trying all kinds of chemicals and all kinds of protein bases against AIDS and see what sticks. Just have a machine do it, fully automated. Because statistical models really do have that power. And the interesting piece about the machine learning solution here is that because there's a lot of learning we have to do as an industry, it's kind of applicable for all skill levels. At the basic level, there's a small drag and drop menu where you can, even as a general purpose developer, just click together, hey, if those two things happen, deduct that, I don't know.
There's a couple of things in the machine learning piece that I think are interesting for the IoT space. The examples that Felix pointed out were all customer-facing or consumer-facing, right? Amazon, Netflix, I don't even, they're all Spotify. They're all preferences and services, and we can get you to buy something because we know you bought something else. I would encourage you to think of IoT as an iceberg in a way, and the tip of the iceberg is what we see in the consumer space. We see a ton of consumer-facing solutions. But the 90% of the iceberg that's below the surface, I believe, and I believe that we can confidently make the bet on this, is in industrial automation. It's in supply chain management. It's in manufacturing. It's in automotive. It's in systems that we already don't pay attention to, but we want them to be fast, and we want them to be cheap, and we want them to give us value for the minimum cost possible. So imagine instead of Netflix recommending a new movie, what you can do when you go to work is you can stop in at the desk of the guy doing, safety maintenance at the oil well, and he's not staring at a monitor, scrubbing his eyes because he's got to watch 16 gauges and make sure that none of them go over red. But instead, you can say, hey, Joe, how's it going? And ask about his kids, because what he's going to get is a machine learning model that says, based on historical data of all the gears and valves in the pipeline, I know that these valves are the ones that are most likely to fail in the next 3 days. Keep an eye on those.
Right.
That's value to companies in a big way.
Right. So to summarize this whole thing, as far as Microsoft is concerned, we think that those 3 things for the IoT space are currently best in class, but they're very purposefully designed in a way that they can be plugged in into anything else. They can be plugged into the whole mesh that I've been describing. And even if there are other solutions out there that arise that can be integrated, it would be our job to actually integrate those tools with our tools. We don't necessarily expect people to use the full Microsoft solution end-to-end. We do assume that people probably have multiple solutions. But that would be the overarching solution if you think about, okay, we do have a device, it uses first-party technology. What can we, Microsoft, offer as a product to integrate with all kinds of devices?
Just to go back to kind of the why we do open source and how we engage, I want you to imagine walking into a company that does software control systems for on factory floor devices and explain to them how to build a machine learning model, right? So our value is to come in and help them understand that if they can get this part standardized using AllJoin or Olay for process control or whatever the API is, whatever the protocol is, and they can collect that data in aggregate in a standard open way that someone else can do, they can leverage much more powerful tools to become more efficient.
Right. Okay, so let's talk about the actual big piece of today, which is the fully open source solution, which is not a Microsoft product, but it's basically, we now came full circle. If you think about our whole talk as a pyramid, we started with a first-party solution. We said, yes, we're going to integrate AllJoin. It's going to be in Windows. Then we did the next piece where we said, yes, we also have cloud solutions where you can integrate your IoT solutions with our solutions. And then there's the third piece where we think, hey, we see a gap. It's not going to be a Microsoft product. We don't really think we should build a product for this, but there's something we can just throw out into the industry as open source code and see what the industry can do with it and how it can improve the industry. So, Ivan, take it away.
So what we have for you today is a source code repository that lives on GitHub, and it's called AllJoin Cordova, although I often get those words backwards, so it could be Cordova AllJoin. And within it, what we have is we have a plugin that we've developed that works on iOS and Android today. Windows Phone and iOS today. Android is lagging a little behind because I've been giving talks and not writing code. But we have that plugin that's available for all 3 devices. It runs on Windows on the desktop. And with that plugin, you can write applications that speak to AllJoin devices. So what Ville can demonstrate is we have cross-platform chat that works with the standard demos that come with the AllSeen Alliances code out of Garrett. We also have lighting controllers and a television app, so we can interact with the AllJoin compatible televisions. And the point of us writing these and giving them away is that we would like to see more devices hit the market. So we want to deal with the how do you use the devices that are out there now problem, right? Provide a solution so people can go do those partnerships. And we think with this code we can do that. We also offer, a level of partnership and support where if you want to use it, we'd love to hear from you and work with you on actually helping get apps done. And if this takes off, then I think we can see people start to focus more on sticking AllJoin into their devices as they produce them. Right? Because if you think about it, AllJoin devices and AllJoin apps is kind of a chicken and egg problem. If we don't have people who want AllJoin, why will companies make them? So we attack the app side first.
Right. And I think it's interesting to point out that that is one of those things that we built because we made certain learnings with the Microsoft Accelerator. The HeatWorks guys are a good example. just picture for a moment that Heatworks comes to Microsoft, we're giving them a bit of investment, but the main thing Heatworks is getting is that they get mentorship. So they, for instance, talk to the Office team, right? The Office team builds a somewhat popular application. Office today is still one of the most popular applications out there in the world. And if you ask Office, how do I build a successful application? Office sits down and is like, well, it's pretty easy. You just need an application for iOS and Android and Windows Phone. Don't forget about the tablets. You need something native for macOS and Windows. And all in all, it shouldn't cost more than like 5 million. Right? And as any given normal company that doesn't have 500 people doing nothing but building software, that tends to be a bit hard. So what this solution actually enables is that you can very quickly prototype an application that does what it's supposed to do. It's enabling the user experience to a certain degree where the user doesn't hate it. But the most important piece is that it allows you to do it in JavaScript, which is essentially the lingua franca of development today. You can pretty much write anything for anything in JavaScript. So the idea of us releasing this is that we're not only helping the companies that we're working with, we're not only helping ourselves, but the idea is also that if any of you guys out there are building devices and you struggle with building an application for any of the devices I just mentioned, this might be a good solution. And especially Ville sitting over there would probably like to talk to you because he's the guy who actually wrote it. He would like to see it being used more. Yeah.
So the only other point I would make on this topic is the obvious question of why would Microsoft invest in building a Cordova infrastructure that's cross-platform? And the answer comes down to we've made previous investments in Cordova before. You can write cross-platform Cordova apps using Visual Studio on Windows today. And I think that in terms of leveraging our expertise to the problem, this is the right track. Now, will these Cordova apps, performance-wise, ever compete with a native app? No, right? But we can make them look good. We can make them pretty fast. And I think that they get device manufacturers, they take that distraction of I have to go hire mobile developers out of the equation so they can get their device to market with a simplified application development process.
Right. Okay. So let's close it before going to the actual Q&A section. One thing I want to point out, I kept seeing many of you taking pictures. The good news is this presentation itself is open source, which, yes, that is almost a joke, but we did it anyway. If you visit this URL, what it's going to do, it's going to take you straight to the presentation, which happens to live on GitHub. Looks like this. It's actually not PowerPoint or anything. It's just a website. We just built a website. This presentation is actually a website. And you can just open it up, do with it whatever you want.
And show your friends.
Show your friends, right. But just to go back to this, there's also a link, and that might be pretty crucial, to the GitHub repository of the Cordova All-Join project, which is what Ville built with a bunch of sample applications. We are going to be here to show you the sample applications, but if you just want to head off, but you do want to look at the actual Cordova solution, just go and visit this URL. There's going to be a giant button that reads, here is the source code for the Cordova project, and I assume there are probably not many developers in here, but just trust me in telling you that GitHub is like the thing that makes every single developer happy because it allows them to build something very quickly while having quality code. That being said, in the presentation is also all our personal contact details, Twitter, GitHub, email. Get in touch with us. But I think we can open up to Q&A, and I'm going to reiterate that we're going to all stick around, and it would be pointless if we just stood here on stage talking about we want to build partnerships and then take off. So if you're building any kind of device and you feel somewhat lost with me saying that we can probably break into your cloud infrastructure, talk to us.
Definitely.
Okay. Thanks, by the way, for showing up.
Yeah.
I think that's important. We should have mentioned that.
Are there any questions? I see no hands. That means you get all 50. Oh, excellent.
Hello. So is there any plan for having a C# library? I'm a developer into the Internet of Things, and I would really like to have a library on C# or that maybe I can run it on a new Raspberry Pi 2 that you are going to support, I think.
That's an excellent question. So you were referring to the Raspberry Pi 2. Raspberry Pi 2 is supported by Windows 10. One core, the thing that we mentioned, is actually going to run on it. So the bottom line is that we as Microsoft want to make sure that if you're running Raspberry Pi 2 and you're working with devices and your choice is the one core, we want to make sure that you can pretty much integrate with every single thing that we do. At the same time, and this is the interesting piece, if you run your Raspberry Pi 2 with Unix, we still want you to be able to talk to everything that we do, right? And as an industry, on top of that, even if you run your Raspberry Pi 2 on Unix and you're doing something that doesn't touch Microsoft at all, we still want you to use as much open stuff as possible, because we strongly believe, and we've seen this a couple of times, that you will probably fail if you keep your stuff closed, right? Bottom line is, if you build a light bulb and the only way I can turn on your light bulb is with your application, you will lose millions of customers.
I think a more concrete answer to, I think, the tactical part you're asking about is, will you have APIs? I'm going to dodge, but I'm going to dodge it in a creative way, which is to keep your ears open over the next time frame to be determined, because not only did we put the router in Windows 10, but we have announcements we're preparing around other access to AllJoin through the operating system. So if you Google or Bing or whatever your favorite search thing is wherever you live for windows.devices.alljoin, you may see some relevant pieces.
So yeah, we basically there's like a bunch of AllJoin already on Windows 10 today. And we're going to talk a lot more about what our vision is around that in the coming months.